Okay. What else you can compare here? I think the other really interesting thing here that's important, you can see per pupil expenditure is a little higher in the charters. But the really interesting thing is the age distribution. Charter schools are filled with young, inexperienced teachers. So 71% of teachers in the high schools are under 32 years old. They hire kids right out of college with no teaching experience. My daughter, I should say, is in that group. My daughter just graduated from the University of Michigan. She did not study education. She has no training as a teacher. She studied economics and politics, but she decided she wanted to teach in public school, and she teaches in a charter school. And her school is full of kind of enthusiastic college graduates. Many of them come from a program called Teach for America. Teach for America is now the largest employer of American college graduates on elite campuses. Teach for America takes something like 10 to 20% of the graduating classes of schools like Harvard and Yale, also the big public universities, Michigan, Berkeley, and puts them into public schools for a period of 2 years. My son's girlfriend, for example, is doing TFA. So you can see that's a dramatic difference. Young teachers, by definition, inexperienced. Very few old teachers, where old for these purposes is 49. So 9% in charters, but 35% in charters. So that's an interesting picture of what the difference is. And I have some description of our data here. I think I'm going to skip those details. I'm happy to talk to you about that later. Let me just mention the different types of outcomes. So I'm going to start by recapping the MCAS. The MCAS is the test score, the NCLB test score. So that's the test score. That's our Massachusetts test. Every state in the United States has a test system in either every grade or most grades. New York has the Regents exams. Massachusetts has the MCAS. Louisiana has a system. Texas has the TAKS. So I'm going to show you some of those results just to warm up. But the really interesting results that we have now are the AP and the SAT, and the data from the National Student Clearinghouse, which is a national database of college students. You can take any database in the United States on young people, and you can find out where and when they went to college, because the federal government keeps track of that for reasons that have to do with the way our post-secondary system is financed. So you can get permission to do the matching. In fact, you as a researcher don't have to do the matching yourself, because school districts now do the matching. So Boston matches to the NSC. Boston also matches to the College Board data on AP and SAT, and then they share that with us. We have data sharing agreements between our center and the state and the city and all of these organizations. So the first question that I want to just put out there to motivate is college prep. And I like to give a couple of quotes from the schools, because I'm going to show you that this is potentially misleading. Here's a quote from Match High School. Match High School is one of the most successful charters in the country. We know that from our research. Match High School claims 85% of our graduates enter four-year colleges. With one or two exceptions, the remaining 15% enter two-year colleges. So they're claiming a 100% college enrollment rate. Boston Collegiate, that's another charter school. Boston Collegiate has consistently brought its mission to life. 100% of our graduates have been accepted into college. I'm going to show you mostly positive results for the charters, but I'm also going to show you that this sort of claim is highly misleading. It's misleading for two reasons. First of all, the college enrollment rates that are being quoted are for high school graduates, but many students here do not finish high school. So really what I need to ask is, relative to the cohort that starts, how many end up in college? Of course, if only a third are left and those are the best students, then they all go to college. So that's one problem, the sort of selective attrition. And then there's just general selection bias. The kids who go to charter school are not necessarily comparable to the kids who go to other schools. They may be more motivated or have more involved parents. So you should all, when anybody ever gives you a kind of a fact like that, you need to question it and say, well, what's the control group? Who are you comparing it to? What's the reference population? So we try to solve those problems, okay? And the way we solve those problems is we use lotteries and we follow everybody. We don't just follow the graduates. We follow the applicants. We take a set of applicants and we match them into the outcome data. We control for differential risk. Each lottery is a little bit different. It's not like the state lottery where the risk of winning is about the same every year, but it depends on how many people who apply, and so you need to adjust for that. And then we also adjust for compliance differentials using instrumental variables. The way that we do that is a two-step procedure in econometrics. This is called two-stage least squares. First, we estimate the effects of a lottery offer on charter enrollment, and that's called the first stage. Then we estimate the effects of a lottery offer on outcomes. That's called the reduced form. The ratio of reduced form to first stage is the IV estimate of the causal effect of charter attendance. So it's not very complicated. I'll go through it again, and then I'll skip the more detailed presentation. The first stage is the difference in charter enrollment rates between winners and losers. The take-up rate isn't that high. This is one of the things we were discussing yesterday in our press conference yesterday. Many of the people who are offered seats go elsewhere for all sorts of reasons. So maybe 60–70% of the people who are offered seats go, 20% of the people who are not offered seats go. That difference, 50%, is the first stage. The reduced form is what I showed you in the plots from the earlier paper, the average test score for winners minus the average test score for losers. Since the lottery is random, we think that the only reason why the winners do better, if they do, is because they were more likely to go. And therefore we make the adjustment delta over pi, reduced form divided by first stage, is the causal effect of charter attendance on people who attend charters. That's what that notation means. Y1 is what I'll get if I go to a charter for a given kid, indexed by I. Y0 is what that same kid gets if he doesn't go. C is a dummy for going. This is the effect of treatment on the treated in clinical evaluation parlance, and it's a theorem in econometrics that you can estimate this using random assignment. The key thing is that all of our comparisons are based on random assignment. We never compare kids who go and don't go. We compare kids who are offered and not offered. And then we adjust that comparison for differences in enrollment. That's the lottery method. In practice, we do it a little differently. It's a little more complicated. There's a way to do it efficiently. There's some detail, but this ratio of first stage to reduced form is always the basic idea. So I'm going to skip all these details for you unless there's demand for that. Here's some descriptive statistics about our analysis sample. And one thing that this table is showing as a warm-up, besides the descriptives, is, so here are some demographics. Female, half the kids are female. You can see Boston is mostly non-white school children in Boston. 40% black, 31% Hispanic, about 10% Asian, not that many whites. This is a measure of poverty status in the U.S. If you're poor, you qualify for a subsidized lunch, either free or reduced price. Special education, these are students who get extra disability services. Disability service rates are always very high in American districts, on the order of 20%. About 12% of our students have limited English proficiency. They come from homes where English is not the first language. Usually the alternative is Spanish. And these are baseline scores. Baseline score is some test score from before they apply for the lottery. So for middle school, it's in 4th grade, and for high school, it's in 7th or 8th. Now, what this table is also showing is that kids who are getting offers in the lottery are similar on all these dimensions. So those are treatment control differences defined by lottery status with standard errors, and none of them are significant. Okay, so that shows that we have a good experiment. That's the point of that table. Another thing that you can see there, though, is that there's some positive selection in terms of who applies. So here is a first set of results. You can see that in Table 3. Here's how we present it. There are two offer variables. This is an interesting thing also that we've been discussing with policymakers in Boston. There's the offer you get immediately when the lottery number is drawn, but then you also get a later offer off the wait list. Since the order is random, they're both random, but that's a complication. So the first stage is about 0.23, and then if you divide the reduced form by that, you get a treatment effect of about 0.4 or about 0.457 in math, so those are huge effects. Those are the MCAS effects. And let me show you also the distributional effects. Whoops. So these are compliance-adjusted distributional effects in scores. The MCAS score distribution, for various reasons that don't make much sense, MCAS scores are scaled to run from 200 to 280, and 20-point bands are proficiency bands. Psychometricians love to come up with interesting score scales. The main thing is the winner's entire distribution is shifted to the right relative to the losers. That's math, that's English, and that's math. There's the winners, and you can see we're moving people into high proficiency categories. Now, we also have some results on other things related to MCAS scores, like kids in Massachusetts who have very high 10th grade test scores qualify for a college scholarship. So we're also boosting that. Let me skip ahead and show you some of the later results. These results are impressive, but in some sense, they're just the beginning. And that's because this is what the charter schools do. They want to boost these test scores. Do they boost later scores? So let me show you some of these other results. These are SAT results. And here are SAT score distributions. If any of you have ever interacted with the American college system, you'll know about the SATs if you send a child to college in the United States, or if your children have friends. The SAT is a very demanding exam. It scares a lot of people. Minorities have very low scores on the SAT, and it's a big problem to try to get people to get high enough SAT scores to get into college. And again, you see very impressive score shifts. This is the overall composite. This is the reading, writing, math especially. So huge gains on SAT on an order of a third to a half of a standard deviation of the American SAT score distribution. So again, I don't know how familiar people are with that unit. It's unheard of in social science to produce such gains. So that's really quite impressive.